Hello everyone, welcome once more to another video in our YouTube channel. This is Mathematics Academy for Africa, an organization whose primary aim is to promote the study of mathematics in secondary schools and in universities. This is our e-learning platform, eStudy Universe, where we try to digitally provide solutions to problems that students face while preparing for their advanced level and their competitive entrance examinations home and abroad. In this video, we are going to look at June 2024 Pure Mathematics with Mechanics/Statistics Paper 2, question number 1. This is basically a tips and solutions series program where we try to solve past GC questions, past mock examination questions, and pre-mock questions to effectively prepare students preparing for the advanced level. We are also going to be looking at further mathematics, physics, chemistry, biology, and computer science. So if you're new to the channel, make sure you like, you share, and you subscribe to the channel. If you're viewing this video from our e-learning platform, our comment section is open for you to table your worries. If you're viewing this video from YouTube, our comment section is also open for you to table your worries. Alright, so let's get started straight away. Alright, so this is June 2024 paper 2 of Pure Mathematics with Mechanics/Statistics, question number 1. Now, question 1 was divided into two parts. The first part had 3 marks and the second part had 5 marks. I would like you to pick up your pen and paper, try to solve the question, put down your solution. After pausing the video, when you're done, you can play the video to now see if your method and your solution are both correct. So I'm going to read the first part of the question. It reads, express 4x plus 3 divided by 2x minus 1 times 3x plus 1, where x is a real number different from half and negative 1/3 in partial fractions. Second part, if the roots of the quadratic equation x squared plus k plus 1 other times x plus k equal to 0 are alpha and beta, find the values of the real constant k for which alpha is equal to 2 beta, 5 marks. Now, the first question is from the topic partial fraction decomposition or partial fraction resolution, and the second question is from the topic the theory of quadratics. So these are very two important topics that hardly miss out even in paper 1 of the GCE for both mechanics students and statistics students. So endeavor to follow up the solution. Like I said, if you have worries, the comment section is open for you to ask. Alright, so we are going to begin with the first part of the question, partial fractions resolution. Express 4x plus 3 divided by 2x minus 1 times 3x plus 1 in partial fractions. Now, I would like you to note down some things I'm going to say which I'm not going to write on my screen, so you have to be very attentive to what I'm going to say. Now, when we want to resolve or when we want to express a rational function in partial fractions, all we have to do is first identify the type of fraction. There are two types of fractions. We have a proper fraction and we have an improper fraction. For a proper fraction, the degree of the polynomial in the numerator is always less than the degree of the polynomial in the denominator. For an improper fraction, the degree of the polynomial in the numerator is greater or equal to the degree of the polynomial in the denominator. In this case, the degree of the polynomial in the numerator is 1 because it is a linear function. The highest power of x is 1. In the denominator, the degree of the polynomial is 2. Why is it 2? Because we are multiplying two linear functions. So when we multiply polynomials, the degree of the resulting polynomial is the sum of the degrees of the polynomials we were multiplying. I am multiplying a polynomial of degree 1 with a polynomial of degree 3. So definitely I'm going to get a polynomial of degree 2 because I need to sum degree 1 plus degree 1 gives me degree 2. Now, degree of the numerator is 1 and degree of the denominator is 2. 1 is less than 2, so this is a proper fraction. So when it is a proper fraction, we go straight away to the partial fraction resolution. If it is not a proper fraction, we first of all carry out long division before we start the partial fraction resolution if necessary again. Alright, so in this case, I now have to go back to my denominator and check if the polynomials involved are already reduced to their most simplified forms. 2x minus 1 is the basic form of a linear. In fact, it is the most reduced polynomial of a degree greater or equal to 1, and 3x plus 1 is also a polynomial in its most reduced form. If maybe the polynomial in the denominator here was a quadratic which was not factorized, we have to try to see if we can factorize it. If we can factorize it, we need to factorize it and express it as a product of its linear factors before we start the partial fraction resolution. If it cannot be factorized, then there are forms that we are going to use. Anyways, you can check out some videos in this e-learning platform concerning partial fractions. You can purchase the course so that you see the full lesson on partial fraction resolution. Alright, so let's go straight away into the solution for this question. I think the tips I've given you guys are helpful for you to be able to solve some partial fraction questions which are not exactly this type. Alright, so 2x minus 1 is a linear factor, so its numerator has to be a constant, and 3x plus 1 is a linear factor, so its numerator has to be a constant. So we are going to separate this rational function into two different partial fractions, where one has a denominator of 2x minus 1 and the other has a denominator of 3x plus 1. Now, since 2x minus 1 and 3x plus 1 are all linear factors, the numerators of their separate partial fractions will be constants. Alright, so this is what we are going to say. We are going to say the rational function is a constant on 2x minus 1. We are writing a constant because it is linear, alright, plus another constant over 3x plus 1. We are putting a constant because it is also linear. In case where it was quadratic that was not reducible, because if you are a quadratic that is reducible, we are going to reduce you and express you as a product of your linear factors, and automatically when we separate your linear factors, we're basically going to have constants in their numerators. But if the quadratic was not reducible, then the polynomial in its numerator is going to be linear. Okay, so since we have 2x minus 1 which is linear, the numerator must be a constant. 3x plus 1 is linear, numerator must be constant. Now, in the case where maybe the denominator was a quadratic that was irreducible, maybe if it was something like, I can say x squared plus 1. Alright, x squared plus 1 is an irreducible quadratic. There are no values of x that when you square and add 1 to it, the result will be 0, so it is irreducible. Basically, x is a real number in this case, so the numerator is not going to be a constant, but it's going to be linear, so we are going to say ax plus b. Okay, so in the case where we have a quadratic in the denominator that is irreducible, when we are separating in the partial fractions, it must carry a linear numerator. Alright, but since we have a quadratic in the denominator that is already linear, its numerator must be a constant, and so on and so forth. So the first thing to do is we need to write down the partial fraction resolution form of the rational function given to us. Now we just have to do the LCM. Alright, so we have the LCM is 2x minus 1 times 3x plus 1. When we take 2x minus 1 times 3x plus 1, we divide by 2x minus 1. We are basically going to have 3x plus 1. We multiply with a, we are going to have a into 3x plus 1. We take the very product and divide by 3x plus 1. We are going to be left with 2x minus 1. Then we multiply by b to get b times 2x minus 1. Now we realize that this rational function on the left hand side is having exactly the same denominator as a rational function on the right hand side, so they must definitely have the same numerators. Alright, so we just have to equate their numerators. Now I'm going to expand this to have 3ax plus a plus 2bx minus b. Now I'm going to bring the x terms together, so 3ax plus 2bx, then the constant terms together, that's terms that don't depend on x, which is a minus b. Now from the first two terms, x is common, so we are going to factorize the x. We'll be left with 3a plus 2b, and a constant term remains a constant term, a minus b. Now what do we have to do? We have to equate corresponding coefficients, all right, because the two polynomials on the left and the right hand side are equivalent to each other, and when that happens, we are going to equate the coefficient of the constant to the coefficient of the constant, and we are going to equate the coefficient of x to the coefficient of x. So equating the coefficients, we have a minus b for the constant to be equal to 3, and then we have 3a plus 2b for the term in x to be equal to 4 for the term in x on the left hand side. Now we have to solve these two equations simultaneously to get the values of a and b. So we begin with the first equation and we get a, all right. So I'm kind of using substitution. So from the first equation, a is equal to 3 plus b. If I replace in the second equation, in the place of a, I'm going to replace it with 3 plus b. So I'm going to have 3 into 3 plus b, then plus 2b equal to 4. When we expand, we are going to have 9 plus 3b plus 2b equal to 4, which is equivalent to 9 plus 5b equal to 4. Subtract 9 on both sides, 5b will be equal to negative 5, so b will be equal to negative 1. We have gotten the value of b. Now we need to get the value of a. So you're just going to replace b equal to negative 1 in the first equation, which says a is equal to 3 plus b. So with that, a will be equal to 3 plus negative 1, which is equivalent to 3 minus 1, so a will be equal to 2. So in conclusion, the rational function has been expressed as a sum of its partial fractions. So we have 2 on 2x minus 1 minus 1 on 3x plus 1. Actually it is plus b, but since b is negative 1, positive times negative is definitely negative. So we have gotten the partial fraction resolution of the rational function given to us. If there is a question, the comment section is open for you to ask your worry. So let's go straight away to Roman 2 of question number 1. Alright, Roman 2 reads, if the roots of the quadratic equation x squared plus k plus 1 times x plus k equal to 0 are alpha and beta, find the values of the real constant k for which alpha is equal to 2 beta. So in situations like this, the first thing I would always like you to do as a student is to get your sum of roots and your product of roots. Alright, so the sum of roots is actually alpha plus beta, because alpha and beta are the roots. Now basically we know that sum of roots is negative b divided by a. Your b is a coefficient of x and your a is a coefficient of x squared. So negative b becomes negative into k plus 1, then your a becomes 1. Alright, so we have negative into k plus 1 divided by 1, which is just negative into k plus 1. Now we need to get the product of roots, which is alpha times beta, because alpha and beta are the roots. So the product of roots is generally c over a. Your c is the constant term, which is just k here, and your a is the coefficient of x squared, which is 1. So we have alpha times beta to be equal to k over 1, which is equal to k. Now important information in the equation: alpha is equal to 2 beta. So when alpha is equal to 2 beta, we just come back to our sum of roots and product of roots and replace alpha with 2 beta, replace alpha with 2 beta, and see what we are going to get. So in the first one, you have 2 beta plus beta equal to negative into k plus 1, and in the second, we have 2 beta times beta to be equal to k. Since we are finding the values of a constant k, we are going to eliminate beta so that we have an equation only in terms of k. Alright, so on the first equation here, 2 beta plus beta is 3 beta. So beta will just give us the right hand side divided by 3. Now you still have here 2 beta squared to be equal to k. So for the first equation, your beta is negative into k plus 1 divided by 3. Alright, because when we sum 2 beta plus beta, we get 3 beta, and then we need to get beta. Now to get rid of beta from the two equations, we just have to replace the beta from the first equation into the beta in the second equation. Everything will now be in terms of k, and we can easily find the values of k. All right, so doing that, we are going to have 2 times what is beta, negative into k plus 1 over 3, but we need to square, then we equate to k. When we square the negative sign, it becomes positive. All right, now we are going to square k plus 1, then we are going to square 3 and just cross multiply. Then 2 will multiply the k plus 1 all squared, and then when we square 3, we are just going to cross multiply because it stays in the denominator. So doing that, when we square k plus 1, we get k squared plus 2k plus 1. When we square 3, we get 9. Since it's in the denominator, we cross multiply. We have 9 times k to give us 9k. Now this is going to give us 2k squared plus 4k plus 2 equal to 9k. Now 4k minus 9k is negative 5k. Alright, so you can try to write it down because I never had time to actually write down all the steps, so it's important that you follow what I'm saying. So we are going to have 2k squared minus 5k plus 2 equal to 0. We can now solve this by using any method of our choice, but best method here is factorization or the quadratic formula. I'm going to go through factorization. The factors of 4 that when we add, we have negative 5, we multiply, we have 4, negative 4, no, we have negative 4 and negative 1. All right, so when we factorize this quadratic, we are going to have 2k minus 1 times k minus 2 equal to 0. Now we need to solve. Equate every factor to 0. We are going to have k to 2k minus 1 being 0, k is equal to half, and k minus 2 being 0 means k is equal to 2. So these are the values of the constant k for which alpha is equal to 2 beta. Now alpha equal to 2 beta means that one of the root is double the other. All right, so they could see set this question saying that find the values of the real constant k for which one root is double the other. All right, so if one root is double the other, we still get back to this condition of alpha is equal to 2 beta or beta is equal to 2 alpha. All right, so we have two values of k equal to half and k equal to 2 for this condition to be met. All right, thank you guys for watching. See you guys in the next video of question number 2. If you have a problem, the comment section is open. Until then, stay blessed.